Okay, so negative exponents. This is a whole new territory, but it is really easy to understand if you follow the steps right. Now, if you have, like this example I've written, 3 to the negative 2. Now, that is a power where a power that it's not happy. It's not happy because it has a negative exponent. Okay? The way you make powers happy is, you see right now this one, is on the top in the numerator. Okay? If you put it on the bottom and change the exponent from negative to positive, then it's happy down there. So this is the same thing as 1 over 3 squared, which is the same thing as 1 over 9. So if a power is not happy, it will tell you. That means move me. If I'm downstairs, move me upstairs. If I'm upstairs and I'm unhappy, move me downstairs. If I'm upstairs and I'm happy, leave me alone. If I'm downstairs and I'm happy, leave me alone. Okay? So, just because of time, we're just going to go through past the chart. But if you had a to the negative n, what is the way I could write that with positive exponents? Matthew.
1 over a to the n.
1 over a to the n. Do you see the power was not happy upstairs? Put it downstairs and change the exponent. How about 1 over b to the negative n? Is it happy downstairs? So how could I rewrite it? Yes?
B to the n.
You actually just write it b to the n, because over 1, if you want. Okay? Now how about this one? This is a nice one. A over b to the negative n.
B over a.
Yes. B over a to the n. Okay? Can I explain that one by, this is the same thing as a to the negative n over b to the negative n. Because you can go like this. Now, right now, is either a or b happy? So, to make it happy, this would be b to the n over a to the n. And since they're both to the n, you can take it out, and it would be b over a to the n. And do you see that's the same conclusion that Matthew came up with b over a to the n. Okay, now the best way to really understand these is to do examples. So we're going to spend the rest of the period just going through examples, and you can start now seeing how these work. Now 4 to the negative half, that is a negative power, negative exponent. Is it happy upstairs? So make it happy first. So it would be 1 over 4 to the 1/2. Now we couldn't do it in the original form, but now we can. Because this is the same thing as 1 over, what is 4 to the half? 2. Now did I half 4? Is that how I got that? How did I get that? Square root, because this means square root 4. 4 is one of the worst numbers to deal with in mathematics for examples. It is, because if you square 2, you get 4. If you multiply 2 by 2, you get people to think, oh, that means 2 times 2. Why? Because it equals 4. Okay, you got a point there. Okay, but how about this one? That's 6. No, it's not. It's 9. You're like, oh. Okay, so 2 squared. 2's are bad. 2's, 4's, you got to stay with for examples. I didn't make this, but okay. How about B? 9/16 to the 1/2. Is it happy? Yeah.
9,
So that would be, yes. Shh, you guys. Right, make it happy first. Don't try doing 2 steps at one time. That is probably, well, that is where the greatest errors come in. You can be too efficient in mathematics, and what it does, you just get the wrong answer. Now, I can take, that means, just so you know, you guys, this means 16 to the half. That's what that means. What do we think of a half? That's our square root. So this would be, no, 4 over, don't half it. Yes. 1/2 means square root, right? Yes. No. Oh, if it was like this, but it's not. It's just talking to the 4. Where the question that we have, it's talking to all of it. This is all in brackets. If it was just, okay, you guys, we're not talking, right? If it was like this, it's only talking to the 16. The brackets are a huge deal. Okay, next one. Okay, putting up your hand, let's make it happy. Who could tell me how to make this thing happy? It's all about making it happy. Yes, Tati.
Do like the negative and 27 over 8 bracket on it.
Good. Now, here's always the $1,000,000 question. Where does that negative belong? Should I put it on the top? Should I put it in the middle? In the bottom? Goes to both? No. Mm-mm.
Oh, it goes to the top.
It goes either to the top or the bottom. If this does not, like, let me write this down somewhere so you guys have it. Negative 27 over 8 does not equal negative 27 over negative 8. So we don't go to both. Because if you went to both, that turns it into a positive. Right? Because this is actually positive 27 over 8. And negative 27 over 8 is not the same thing as positive 27 over 8.
then it would be 27 over 8.
Or negative 27 over 8. Okay? I always put the negative on the top. It doesn't matter. Just put it one place. So I don't ever put it in the middle. I just put it in the top all the time. So what's the cube root of negative 27?
3.
Negative 3. And the cube root of 8? 2. So the answer is negative 3 over 2. Okay, so everybody just take a look at those 3 examples. Any questions? Don't be scared. We've had lots of questions today. You must feel comfortable enough. Yes? No, 1/3 is the exponent. That's cube root of, yes? And you guys, when we're all going to think things differently and stuff, let's not jump on people when they ask a question, right? Because then it's not a good place to even be in here. Yes?
Why, when it's in the middle, does it only apply to one? Because when does there have to be 2 negative signs for it to that thought?
Yes, there would have to be 2 negative signs for them both to be negative.
And
Just like on the quiz today. We had on the quiz today, remember? 2 negatives, and I said get rid of them, make them a positive.
oh yeah, yeah.
There's 2 negatives, it's just positive. Yep. The exponent in the middle? The exponent won't be in the middle. It'll be on the outside.
No, like the negative, the exponent, like the negative one.
Oh, the negative doesn't matter again. I put, when it's an exponent, I keep it in the middle, because then when I do the flip, I just get rid of it. right? So when you have a over b to the negative 1, that's just b over a to the positive 1. If it was a positive, if it was a negative 1/2, it would turn into a positive 1/2. Okay? Okay, these should insult your intelligence. 4 to the negative 1 would be
1 over 4.
okay, how about hands from now on? 2/3 to the negative 1. How would you write that so it's positive? Yes?
Uh, 3.
Okay. 8 to the negative 2/3. Question or, okay?
Oh, but you put the ones down.
No, I just wanted to because if I didn't, I'd have 5 hands up going, where's the 1? What'd you do with the 1?
Yeah.
So this is what I would do next. Okay, 8 to the negative 2/3. Okay, hands up. 8 to the negative 2/3. Yes. Okay. Now, can you do anything with 8 to the 2/3? That means 1 over, what's going on the outside? 3 and 2, right? So, the cube root of 8, 2 squared, so this would equal 1 over 4. Okay? D. I just want them positive right now, and then we will worry about simplifying. Okay? How would you do D? Yes. That makes sense?
4 over.
Yeah, you can put 4. You put that negative anywhere, I always put it on the top. Now, we can cube negative 4, right? And that is, no, cube root and cube, or, well, square root of 4 is 2, but 64. Do you see how there's a 3 out there? To the 27. It is negative. Negative 64 over 27. Now D, see how we haven't had fractions, or we haven't had decimals up to now, but you can change it to a fraction. What is 0.3? No, 3 over 10. So this is like 3 over 10 to the negative 4. Okay, now have I done any calculations at this point? No, I just, and if you're like, oh man, I would have never got that, just go 0.3 math, enter in your calculator. And it will give it to you. Now, what would we do? You want to try it? Yep.
10 over 3.
Okay, and then we can do it. 10 to the 4th is 10,000, and 3 to the 4th is 81.
Wait, is that really equal? Okay,
Yes. Okay. Okay, guys, we just stop playing with the pencil sharpener. I need you guys to focus here. I just took this thing and I changed it to 3 over 10. Now, if I did this, that wouldn't equal the above. Right? If I just did the negative 4 to the 3, that would be, you want all of 0.3. Yes?
How do you go on your calculator with those forget?
The exponent button is just above the division sign. So 10, exponent 4. Okay, 9/16. to the negative 3 over 2. Let's make this happy. Who could tell me what it would be if we made it happy? Okay, don't yell it out. Yes?
16 over 9. Or
Now, that means to do 3 over 2 to each of these. So if I put 16 here and 9 here, what's going outside the 16? 2 and then the cubed. Same here, 2 and the 3. So that means square root 16, which is 4, and 4 cubed is 64. Square root of 9 is 3. 3 cubed is 27. Okay, just in case you were getting this, let's do some hard ones. Didn't get which one? Be specific. What part did I lose you?
No, I mean these others.
Oh, well, we haven't done them yet.
These two letters, yeah, they look scary.
who decided to put the alphabet now?
Hmm?
Who decided to put the alphabet now?
Who decided to take it out?
Oh, I don't get it.
Okay, so if we want to learn how to do these, you got to work with me here. Now, the trick to doing when there's a lot of stuff is work from the inside out. So if I just concentrate on this right now, do you see I have a scenario where those bases are the same? If the bases are the same and they're multiplying to each other, what do you do with exponents? Add them. So does everybody agree that if you had b to the 4 times b to the 5, that would equal b to the 9? Okay, so this would be 2/5 to the negative 1. Okay, now when I do these in steps like this is when I want you to put your hand up if you're like, I don't get that step. Because if we finish the whole thing, you're like, I don't get it. I'm like, well, what step? Okay, because I can't help you unless you're specific with me. So does everybody get what I did? With the same base, add exponents. Now, the next thing you'd want to do is, can we multiply any power to powers out? We can multiply these, right? It's a power to a power. So what is negative 3 times 1? So now I have 2/5 to the, what do you say? Negative 1 times negative 3? Positive 3. So if they look scary, work from the inside out, and it's not so intimidating now. What is 2 cubed? 8. 5 cubed? 125. Okay? Well, you would have had to, okay. I can do it that way too, but I'd have to work from the inside out. So do you have to, can I do it your way? And you're just going to watch? So let's just do the negative 1. So this would have been 5 over 2 to the 1 to the negative 3. Okay, I've just done that. Now, I want to make it happy again, so it'd be 2 over 5 to the 1 to the 3. And now look what I have. So you can do it that way, it's just a bit more work. If you actually multiply your power to powers out first, before you do that, it'll save you some work. Well, no, I moved. Oh, this one? Yeah, power to a power. Remember, you multiply. Like if you have b to the 2 to the 5, that's b to the 10. Okay, and that's, remember all those laws I did with you guys before, and you're forgetting them? It's because you're not doing study sheets. Yep.
So I'm a little bit confused. How can I multiply like the make in step 2? first step. How do you know to multiply? You take 1 times negative.
Always multiply your power to powers.
I thought we were at.
No, you add when, see if it was b to the 2 times b to the 5, that's b to the 7. But if you have b to the 2 to the 5,
Oh,
that's 10.
yeah.
Okay. Now, working from the inside out. I'm going to ignore the negative 2 out there. But, can I take 24 and divide it by 6? You will get 4. Okay? Now, that negative 2 staying outside. Does everybody see this now? X to the 2 divided by x to the 3. What can I do with these exponents? So that would be x to the, no, x to the 2 minus 3.
Oh,
Now the y's, do you see I can subtract the exponents of the y's? Negative 4, treat this like a big minus sign when you do these. Negative 4 minus negative 1.
Negative 5.
Negative 4 minus negative 1 is the same thing as negative 4 plus 1 is negative 3.
oh yeah.
Okay, one at a time. Yep. 24 divided by 6. Yep. x2 divided by x cubed is 2 minus 3. We subtract exponents. Yep. Okay, well, I'm not there yet. Okay, I'm not done. Okay, you guys, we're talking to each other. I need you looking up here. Now, you see how the negative 2, it says, I'm not happy. So you could flip everything upside down. But what did I say you should always try first? Multiply the powers in. Now, this is a 1 right there, okay? So I can do this. You just got to make sure you do it to everybody. So this would be 4 to the negative 2, x to the 2, and y to the 6. So I'm not really flipping anymore because I don't have a big exponent outside. But I can make somebody happy because there's one power that's unhappy right now. And it's this one. It doesn't want to be upstairs. So we only do flipping when it's outside the brackets. But I said you can flip. You could have flipped at that stage, but it makes more work. Do all your power to powers, and it'll make things easier for you. So this will be x squared, y to the 6, all over 4 squared. Now it's happy. You can simplify 4 squared to be 16. So this would be x squared y to the 6 all over 16. Why did I put the 4? Okay, let me do the, is this power happy? Is it now? And I moved it downstairs and changed the exponent. No, well, the 1 is right here. If you really wanted to,
Oh,
like, do you guys know that, like, say 1/4 a is the same thing as a over 4? So I just put it downstairs. You can leave a 1 up there, but when you have an x squared, it means 1x squared. It's like if you say I have a dog, people don't usually go, how many? Right? It's applied. Dog means 1. And x squared, there's always an invisible 1 there.
if there was already an X there, which like I don't really understand. side would be like 2. No.
Okay, let's do this one. Now, the power to power stuff, do you see there's no big set of brackets for this one? So we're not flipping anything. Now this -3, math has a lot of subtleties in it that if you don't get them, you get the question wrong. Is that -3 talking to the 10?
No.
No, absolutely not. But some people might put it there. Now below, is that -2 talking to the 8? Okay, so that's the difference. So I put ones, why would I put a 1 there and not on the 10? Because I'm not going to multiply my exponent on that 10, so I'll leave it alone. But I'm going to do these. And down here, I'm going to do these. So for C, let's just talk about the top. That would be 10 p to the -9, q to the -6, and r to the 0. Now what is r to the 0? 1, yes. So if r to the 0 equals 1, what happens when you take r to the 0 and multiply to all of this? It's just going to, so you can actually get rid of it because it equals 1. Now on the bottom, it would be 8 to the -2, p to the 6, q to the -10, and r to the -6. Now, again, do you see if you multiply one wrong, how you're not going to get this answer? Now you have different things you can do here. You can go and subtract p's and q's and all that stuff, or you can make everybody happy. Okay, let's just finish this. So if I made everybody happy, it would look like this. 10 is this, let's just do the top. Is this happy? So put it below would be what? P to the 9. How about, keep going on the top. Is this up? So Q to 6 would be down below. Let's see the bottom. Is 8 to the -2 happy? So you move it up top. How about P to the 6? So you leave it there. How about Q to the -10? Unhappy, bring it up. And R to the, bring it up. Okay, so on the top, what's 10 times 8 squared? I'll just tell you, it's 640. And let's just do Q10, R6. Because I multiplied those two together. Is there anything I can get together in the bottom? That'd be P to the 15, Q to the 6. Now there's one more thing I can do, and what's that? I can subtract the Q. So 640 would be Q to the 4, R to the 6, all over P to the 15.
So it stays on the top though?
It stays on the top, yep. 10 minus 6 is 4. Okay, and there's the assignment. Gotta love Thursdays. My brain's dry too. Oh, I'm still taping, and that went on there.